All right, here we go. We're going to fire away at section 9.2, characteristics of quadratic functions. So again, well, I actually have it right here. I'm not going to rewrite it. I have the general form right here from yesterday. The bottom. New today is talking about what a zero of a function is. It's kind of interesting. It's a word that, you know, I ask about zeros on quizzes or tests, and then the minds are blank. So try your best to lodge that into your memory bank. So zero of a function is the same as the x-intercept. Or there could be, I'm putting an S because there could be two of them. So wherever the parabola hits the x-axis. So if you have that, and then you have a parabola that goes right like that, these are your zeros of the function. Okay? There could, well, here's the question. How many zeros can it have? So this one would be an example where there are 2 zeros. But could we do something like that? How many does that have? That's an example of 1 0. And could we do something like that? That never touches the x-axis. So that one has no zeros. So again, how many zeros can it have? These are only options. It can have 0 if it never hits it. It can have 1 if the vertex is on it. And it can have 2. And of course, those could be shifted left and right as well. But it could have 0, 1, or 2. Now, what is the axis of symmetry? Well, you know what a symmetry line is, right? When you draw something through. And in this case, I'll just tell you the axis of symmetry for all the ones I drew is right here. It's that part that when you flip the parabola, it lands on the other side perfectly. So, it is a vertical line. So vertical, you know, up and down, that divides the parabola into 2 symmetrical halves. The axis of symmetry, always. You don't see a lot of always in sentences, but this one has an always. That means 100% of the time. The axis of symmetry passes through the, does anybody know? Vertex. So like the vertex would be down here. Oops, I'm off the charts again. The vertex of this parabola is here. It's on the axis of symmetry. The vertex of this one is here, and the vertex of this one is here. All of them, no matter which parabola I picked, were on one that highlighted symmetry line. Now there's a formula for axis of symmetry, and this is important. So make it nice and clear and neat. It's the opposite of b, or negative b, over 2 times a. Let's get that highlighted. Axis of symmetry. Opposite of b over 2a. We're going to use that a lot. Put it in your brain. Memorize it. Okay? All right, let's go on here. What does it say? What are the directives here? Find the what? Find the zeros. Do we need to panic? No. No, we don't. And especially if you're given the graph. That's like the easiest question in the world to ask. What are the zeros? What did we say the zeros were? Up above. We said they were the x-intercepts. Where is the x-axis? Right there. There's my x-axis. Where does the parabola hit them? Oh, right there and there. Those are the zeros. This one has 2. Remember we said there could be how many? 0, 1, or 2. This has 2. So you literally just put what it is. You don't have to put the whole coordinate. So you're 0 because they already know it's on the x-axis. So you don't always have to say like -1, 0 because we know it's a 0. So you can just put -1 and then this one is 1, 2, 3. Those are the zeros. All right, guys, tell me what the 0 is of that one. Or zeros, if there is any. Because remember, you could have 2, 1, 2, you could have 1, or you could have 0. Yep, the 0, here's my x-axis. We're looking for where it hits the x-axis, and it's right here. And that is 1, 2, 3, 4. -4. This one only has 1. The vertex falls right on the line. Jump over here. So even though I gave you this whole equation up here, I didn't have to do anything with it because I had the graph to use. What are the zeros in this one? Correct. There are no zeros for this. This is my x-axis and my graph never hits it. Okay, so highlight those x-axes so that you can see them. Now, I'm going to move this down instead of moving that up. Now what are we looking for? Find the axis of symmetry. Okay, we learned a formula for that. You just ingrained it in your memory banks. What was it? X, look above. Opposite of B over 2A. You're like, okay, all is fine and dandy, but I don't know B and I don't know A. Well, actually, now that we're looking here too, we have the picture. We're going to use that when we have an equation like above here. When we have just an equation, we can use the formula. So hold on to that thought. We're going to actually just use the picture now. We know the axis of symmetry always goes through the vertex. So for both of these, our axis of symmetry will go through those vertex. So let's just draw it, just so you can see it. That is the axis of symmetry. But what is it? Well, any vertical line, remember, how do we write a vertical line? It's always of the form x equals. X equals. In this case, it's x equals, what is that there? 0 is up here, so that's a -1, even though I missed it completely. But that would be the symmetry line. The axis of symmetry, x equals -1. It's a line. It's x equals something. We didn't need the formula there yet, but we will in a moment. Okay, let's draw it on here now. Draw your vertical line through. And again, it doesn't matter where I draw a vertical line. It's always going to be an x equals, and I have to figure out where that is. Now my line isn't perfect, but you can tell it's going about halfway through there, isn't it? So it's 1, 2.5. X equals 2.5 or 2.5. Let's say you couldn't tell. Well, you can still look here and see, well, this is a 1 and this is 4. So you can find the middle of that. 1 plus 4 is 5, divided by 2 is 2.5. So you can always average them out as well. Okay, so now we're going to move on to the next page where I believe we're going to use the formula. There we go. Here we go. We're going to use the formula up on top here, because here it says to find the axis of symmetry, but I don't have a picture. So it's the same directives, no picture. That's where we're going to copy that formula down. Like that. And again, you're like, okay, don't know what the A, B, and C are, but yes, you really do, because that formula on the front you highlighted, and it looks like that. So you know that the A is before the x squared. It's -3. the b is before the x, it's 10. And the c is the number by itself, it's 9. Okay, so I'm just going to write those here so that it's clear for you. So a is -3, b is 10, and c is 9. Let's plug it in. X equals, so you can think of this as -b or the opposite of whatever b is. So in this case it's a 10, so it's going to be the opposite of 10, which is a -10. Or you can just plug that value in and have a -10, however you want to think of it. Over 2 times a, so it's 2 times a -3. X equals -10 over a -6. And how does that reduce down? That's right, it's x equals 5 over 3. The two negatives give you a positive, and then you divide the top and bottom by 2. All right, then we jump over to this situation where it says find the vertex. Okay, again, this one has a picture and this one doesn't. So there's kind of different methods with it. If there's a picture, you can oftentimes figure it out by looking at it. The vertex is right between, so you see where these zeros are? Let's go in the middle of that because that's where the vertex is going to drop down. So over 1, 2, over 1, 2. Here's my middle, right through right through that point. And we can tell it's also lined up with -1. So I can figure out the vertex right here. It is 1, 2, 3, 4, -4, and going down 1, -1. Because remember, the vertex is a coordinate. Now, here we go. We don't have a picture. But I am going to remind you that what did we know about the axis of symmetry? We knew that the axis of symmetry always goes through the vertex. So if we go ahead here and find the x, or the axis of symmetry, we're halfway there because we have the x. Okay, so that's where this gets kind of fun. First step is find axis of symmetry. I'm just going to write it down so when you're using your notes it's a little clearer. So make sure you write that. You start with your formula. And I'm just going to write above it, a is -3, b is 6, and c is -7. So we're going to plug those in. So x equals the opposite of b, so -6 over 2 times a -3. So x equals what? That's -6 over -6, which is 1. Nice. That's easier to work with than 5/3. Okay, so if we're finding a vertex, that is a coordinate, and I have the 1. Now I'm going to take that and I am going to plug that into my equation for x, and then I'll be able to figure out the y. So plug x into equation. All right. Now my battery's going to die. That's just fantastic. Hopefully I make it. All right, y equals -3 times 1 to the second plus 6 times 1 minus 7. So I literally was just copying this down, plugging the 1 in for the x. Now, order of operations, we square first. 1 to the second is 1 times -3 is a -3. Plus 6 times 1, we do that next, minus 7. And now we go left to right. See here, we get a 3 minus 7 is a -4. Yay! There's my answer. This is the answer to the whole problem, right there. It asks you to find the vertex. It's a coordinate. Coordinate. Answer. Answer. Okay? So now you can try. So if you don't have these on your sheet, feel free to copy this problem down and find the axis of symmetry and find the vertex. So you can stop the video and try it. And then I've got one extra cool problem at the end here to go through. It's one of my favorites. I know you've never heard me say that. So axis of symmetry is opposite of b over 2a. A is 5, B is a negative 10. Don't forget your negatives. C is 3. So opposite of B. Oh, here we go. See, that's a negative 10. The opposite of B then would be 10. Because if you put a negative, negative 10, they cancel out. 2 times A. Oh, 10 over 10. That's a 1. My axis of symmetry is x equals 1. But that is the first step to figuring this out, because I need a coordinate now. So I'm going to take that 1 and I'm going to put it back in the equation up here. Y equals 5 times 1 squared minus 10 times 1 plus 3. Y equals 1 squared is 1 times 5 is 5 minus 10 times 1 plus 3. 5 minus 10 is negative 5 plus 3 is negative 2. Put it in there. There is your answer for the vertex. Okay, so now here's the applied problem, which I think is kind of cool. Let's read it together. The graph f of x equals negative 0.06x squared plus 0.6x plus 10.26 can be used to model the height, so this is representing the height, in meters of an arch support for a bridge, where x represents the horizontal distance in meters, horizontal distance in meters from where the arch support enters the water. I think it's supposed to say arch supports enter the water. Can a sailboat that is 14 meters tall pass under the bridge? Okay, so it's kind of a cool question because, you know, it's all these different bridges, but if you throw it on an coordinate plane here, we can get an idea of what's going on. So here is my 0, 0, and I want you to picture my bridge like that. Let's extend that out. X-axis. And what is it saying here? It's saying that, let's put our little thing, I'm going to write it over here so it fits on here. Okay, so if I only knew something about this problem, and I do, I have the equation. Because if you have the equation, what did we just learn you can figure out? You can figure out the axis of symmetry, can't you? And you can figure out what's this part called up there. The vertex. If you know the vertex, do you know the height of the bridge? Of course you do. That's a coordinate. You would go over some certain distance and up a certain distance. The y coordinate for that vertex will tell you the height of the bridge. Isn't that cool? Oh, it's so cool. Okay, so we are going to figure out the axis of symmetry first. So we need our formula. X equals opposite of B over 2A. And let's go over here. My A is a negative 0.06. My B is 0.6. My C is 10.26. Okay, so that is equal to the opposite of B, so negative 0.6 over 2 times A, which is negative 0.06, So what is the axis of symmetry? Can you guys see it? So 2 times 0.06 well, negative divided by negative is positive. 0.6 divided by, so you're already seeing what this is going to be. Oh, huh. It's 5. Wow. That's pretty cool. This axis of symmetry is x equals 5. Okay, can we get the vertex now? Yeah, because we already have the x. We just now need to plug that into our equation to get the y. So let's do f of 5 equals negative 0.06 x squared. If this battery goes out before I'm done with this, there's no telling what will happen. I want to finish this. Okay, so if we put in the 5, oh, I never put it in there. Oh, well, I'll just rewrite it. Negative 0.06 times 5 squared plus 0.6 times 5 plus 10.26. You guys should be grabbing those calculators out and helping me out here, because then we're going to have the 5 squared times 0.06. So this is negative 1.5 plus 0.6 times 5. You guys could probably do that in your head. What is that? That is 3 plus 10.26. So we have f of 5 equals, well, negative 1.5 plus 3 is a positive 1.5, plus the 10.26 leaves me with 11.76. That is your y. 11.76. Okay. What's the answer to the question? That tells you that this went over 5 and it went up how far? Yes, this is 11.76. Will that sailboat that is 14 meters tall pass under this bridge? No. Oh, right, bad timing there. No. You will get the top of your sailboat ripped right off. Okay, it's not even 12 feet. Or 12 meters, sorry. It's 11.76 meters. So, wouldn't be sailboating under that. See? You never know when you're going to use math. It's kind of crazy. All right, so that is it. So I hope you enjoyed that problem. I just think that is so much fun, because you just see how they use these parabolas and math and in these engineering and bigger fields like this. It's so cool. So take care, and we will talk to you next time.